We've got a scientist who's studying the population of lizards, which is N. That's in terms of time in years. It's got the N in terms of T, but the dn over dt is in terms of N rather than T, so we're going to have to do a bit of work later on for our 5 marks. Right, find the number of lizards, start the study, so we'll put T is equal to 0 in, so we'll have 1800 over 2 plus 3 e to the 0, and that e to the 0 is just 1. 1800 over 5, which is 360. Multiplies the upper limit to the number of lizards, so we're going to find out what happens as T just gets bigger and bigger, goes off to infinity, and this e to the minus 0.2t gets closer and closer to 0, so it's 900. Find the value of T when N is 780, sticking 780 in for N. We can flip these over, cancel this down, get 30 over 13, so I'm going to subtract that 2 and divide by the 3 and get 4 over 39. And I flip it, so it says e to the 0.2t, which you don't really need to do, but that it means that e to the 0.2t is 39 over 4. Take the ln's, and so I've got 0.2t equals ln 39 over 4, multiplying by 5, sticking in the calculator, 11.4. The second part, we've got n in terms of t, we want dn over dt in terms of n. So I'm going to write this with this bottom line to the power of -1, and you just use the chain rule. So I'm going to have the 1800 when I differentiate it, -1 will go in front, I'll have that bracket to the power of 1 less, which is -2, but then I need to multiply by that bracket differentiated. So I'm going to get this into that form. I've got a bracket to the -2 here, so I'm going to do it as a fraction with that bracket squared on the bottom. I can get rid of those minuses, they'll cancel each other out, and I've got 1800 and 0.6, which is going to be 1080, and then that e to the minus 0.2t. But I'm going to write it, because I've got 3 e to the minus 0.2t here, I'm going to write it like this, because I'm going to rearrange this, so it says 3 e to the minus 0.2t equals, I can work out what that is in terms of n. So here it is, and I'm going to change this in terms of n and this bracket in terms of n by rearranging my initial relationship between n and t. So I can flip these over. So that is going to go here. So 800 over n is going to go here. And then taking away 2, I'll just get the 3 to the minus 0.2t on its own. And that's going to go here. I've got fractions all over the place. So I'm going to multiply the top and bottom by n squared. So I'll have 360 n squared on the top and just 1800 squared on the bottom. And that's level that bracket. But I need to get into this form with 900 minus n. So I need to divide this bracket by 2. So take a 2 out and put n in. So this is going to be multiplied by 2 and divided by n. So I'll still have the 800 squared on the bottom. I'll change this to 900 minus n by multiplying by n and dividing by 2. So this is going to be multiplied by 2 and divided by n. And then finally, cancel it down, divide the top and bottom by 720. I get my A is 4500. State which n is the rate of growth is a maximum. So we need to maximize that top line. And that's 900 n minus n squared. If I differentiate it, I get 900 minus 2n is equal to 0 at a maximum, so n is 450.